Olympus Mons, the colossal shield volcano on Mars, holds the title of the tallest known mountain in our solar system. Rising an astonishing 22 kilometers above the Martian surface, it stands nearly 3 times higher than Mount Everest, dominating the surrounding plains. Its base stretches about 600 kilometers across, wide enough to cover the entire state of Arizona, a scale made possible by countless lava flows spreading outward over billions of years. This gentle giant slopes average just 5 degrees, the result of low-viscosity lava traveling great distances before cooling. At its summit lies a spectacular 80-kilometer-wide caldera, a cluster of overlapping craters formed by repeated collapses after major eruptions. Despite its size, Olympus Mons is geologically young, with areas showing very few impact craters, a sign that volcanic activity may have continued just a few million years ago. Mars's lack of plate tectonics allowed Olympus Mons to grow without interruption, unlike volcanoes on Earth that are limited by moving crustal plates. Towering escarpments, some up to 6 kilometers high, ring parts of the volcano's outer edge, formed by landslides and crustal compression. Ancient heat from its volcanic activity could have melted subsurface ice, creating temporary environments that may once have supported microbial life. Visible even from deep space, Olympus Mons is a monumental reminder of Mars's volcanic power and dynamic geological history. True or false? The base of Olympus Mons is small compared to Earth volcanoes. False. The base is massive, roughly 600 kilometers in diameter, covering an area the size of the state of Arizona. Olympus Mons is classified as a shield volcano. Fill in the blank. Olympus Mons is located on the planet blank. Planet Mars. Fill in the blank. The volcano's height is approximately blank kilometers above the surrounding plains. – 21.9 kilometers. The caldera at the summit of Olympus Mons measures approximately 80 kilometers across. If lava flowed down the flank of Olympus Mons at an average speed of 3 meters per second and traveled 300 kilometers from the summit to the base, how long would it take to reach the base? First, convert 300 kilometers into meters, giving 300,000 meters. Divide this distance by the speed, 3 meters per second, to get 100,000 seconds. Finally, divide by 3,600 to convert into hours, and you'll find it would take about 27.78 hours for the lava to flow from the summit to the base of Olympus Mons. True or false? Olympus Mons is nearly 3 times the height of Mount Everest. True. Fill in the blank. The base of Olympus Mons spans about blank kilometers in diameter. – 600 kilometers. Olympus Mons likely grew so large because Mars. Lacks tectonic plate movement. Fill in the blank. Olympus Mons is composed mostly of blank rock. Basalt. True or false? Olympus Mons formed primarily through explosive volcanic eruptions. False. It formed through repeated lava flows over millions of years, resulting in a broad shield shape rather than steep slopes. If a rover drives for 5 hours down Olympus Mons at a steady speed of 10 kilometers per hour, how far does it travel? Multiply the speed, 10 kilometers per hour, by the time, 5 hours, to get 50 kilometers. You can also convert this to meters by multiplying by 1,000, giving 50,000 meters traveled down Olympus Mons. The flanks of Olympus Mons are gentle slopes. Fill in the blank. Olympus Mons is considered the tallest known blank in the solar system. Volcano. If a lander descends 22,000 meters from the summit of Olympus Mons to its base in 4,400 seconds, what's its average speed? To find the average speed, take the total distance descended, 22,000 meters, and divide it by the total time, 4,400 seconds. This calculation gives 5 meters per second. That means, on average, the lander covered 5 meters every second during its journey from the summit to the base of Olympus Mons. How did you do? Tell us in the comments below. And thanks for watching Brainy Kids. We hope you had fun today. Like, subscribe, and hit the bell so you never miss a quiz. See you next time, Brainy friends.